And once again we are back with the same chapter, that is three-dimensional figures, and this is the last part of the video, that is the fourth part of the video of this chapter. And now we will study about the different types of pyramid, and we will see the verification of Euler's theorem or Euler's formula in different pyramid also. So now the first thing that we will study is about a triangular pyramid. Triangular pyramid is also known as tetrahedron. So now just find it out, the faces, edges and vertices. So let us find out the faces. So first thing, as I told you in the starting only, when we have the base is triangle, it is called a triangular pyramid. So in this we have the base triangle this, and each base, one side is connected with another triangle, this one is connected with one triangle. So this is one triangle, this is second triangle, this is third triangle, and this base is connect this triangle. So this is fourth triangle. So we have four faces. Then edges, so 1 2 3 4 5 and 6. So 6 edges are there. Vertices, so 1 2 3 4. So we have 4 vertices. Now my F is 4, my E is 6, V is 4. So F minus E plus V will be equals to 4 minus 6 plus 4. So 4 is 8, 8 minus 6 is 2. That means for triangular pyramid, or that is tetrahedron also, our Euler's formula verified. So the next one is a square pyramid. Again, square pyramid means the base will be a square, right? And now that means one of my face will be square, and in square how many sides are there, or how many edges are there? 4 edges are there. So each edges will have a triangle and will be connected on the top. So one triangle, this is another two second triangle, this is the third triangle, and with this side we have the fourth triangle. So we have 4 triangles. That means we have total 5 faces are there. Let us find out edges. So 1 2 3 4 5 6 7 and 8. So 8 edges are there. And the next one is vertices. So 1 2 3 4 5. So 5 vertices. That means my F is 5, my E is 8, and my V is 5. So F minus E plus V is 5 minus 8 plus 5. 5 plus 5 is 10. 10 minus 8 is 2. So that means for square also we have verified the Euler's formula. Let us move to the next one, that is pentagonal prism. For pentagonal prism, as I've already told you, it will be a pentagon on the bottom. As you can see in this figure, we have pentagonal pyramid. Now we will see what is a pentagonal pyramid, and now we will prove or verify Euler's theorem or Euler's formula for pentagonal pyramid. So let us find out the faces, edges and vertices. So the faces. So first thing, as we know with the name of pentagon, we will have the base as pentagon. That means one face is pentagon, and each, how many sides are there in pentagon? In pentagon we have 5 sides. So all the 5 sides, all the 5 edges will be connected with one triangle. So that means this side will have one triangle, right? From this side one triangle will be connected, from this side one triangle will be connected, from this side one triangle will be connected, and from this side also one triangle will be connected. So we will have 5 triangles. So 5 triangles and one pentagon is 6. So total we have 6 faces. So the next one, edges. So 1 2 3 4 5. Now just see, from this one side 6, from this one side 7, from this one side 8, from this one side 9, and from this one side 10. So total 10 sides are there, or edges are there. The next one is vertices. So 1 2 3 4 5. These are the 5 vertices of the pentagon, and one as the top, that is the apex. 6 vertices, that means my F is 6, my E is 10, and my V is 6. So F minus E plus V will be equals to 6, 10 and 6. So 6 6 plus 6 is 12. 12 minus 10 is 2. So that means for pentagonal pyramid also my Euler's formula verified. Let's move to the general one. A pyramid whose base is a polygon of n side. Now, which, as we said, whenever we are talking about a pyramid, the name of the pyramid will be based on the base, because a base is what? A polygon, as you can see here. Pentagonal pyramid means one base, that is a pentagon on the base, and each side of the base will be connected to a triangle. So let us see here. We have n sides, that means one polygon will have n sides. Now each side, how many sides? Each side, so n side will be connected to n rectangles, sorry, it will be n triangles. So now we will prove this, the same formula, Euler's theorem, for a polygon when we have n sides. So as just relate the things with the other one. Pentagonal pyramid. In pentagonal pyramid we have one pentagon on the base, and from the base, as we know, for a pentagon we have how many sides? We have 5 sides in the pentagon. So each 5 sides will be connected to a triangle. The same thing here. We will have one polygon of n side on the base. One polygon of n side will be on the base, and each of the sides of the polygon, that means each of the n side will be connected to n triangles. So that means we have n plus 1 faces. Now edges. Let us relate again with the same one. Just see, 10 edges are there. How you are finding out these 10 edges? How many sides are there in the pentagon? 5 sides. So each 5 sides are connecting with 1. So each side will be multiplied with 2, or you can relate with the same thing here. Now we will prove the Euler's formula for a pyramid, but here the polygons is having n sides, that means the generalized one. So let us see, when I said the polygon is having n side, that means my base will have a polygon with n sides, right? The base will be of n sides. And let us see this figure. These two figures we will consider. In this figure, what happened, when we have a square, we have a square base, right? This is my square base, and each of the 4 sides of the square is connected with one triangle. So since we have 4 sides, 1, 2, 3 and 4 sides, so 4 triangles we have. The same thing for this one. We have one pentagon. So pentagon is having 5 sides, and all the 5 sides are connected with one triangle. So here on the top we will have 5 triangles. The same thing here in this question. If you have one polygon of n side, that means the bottom, that is the base, is of n sides. So one polygon will be there of that n sides, and each of the n side will form a triangle. So n plus 1, you will have n plus 1. Next, edges. Again, to find out the edges, let's move to this. We have 8 edges here. How we have 8 edges? Just see. 4 from the base, and each of these 4 are connecting to 1. So 4 multiply with 2. Just have a look in this figure. Just have a look in this figure also. 5. 1, 2, 3, 4, 5, and each of the 5 is connected with again 2. So 5 2s are 10. In the same way here we can write, since we have n sides, so n will be multiplied with 2. So n minus 2 edges. Now let us find out about the vertices. Just see, in this one we have 6 vertices. How? 1, 2, 3, 4, 5, and 1 at the top. Let's see for this question. 1, 2, 3, 1, 2, 3, 4 and 5. That means 4 from the bottom one and 1 from the top. Why 4? Because we have a square with having 4 sides. So let us see for this one. For this figure we have n sides. So that means n vertex will be there and 1 at the top. So n plus 1 vertices are there. So the next one is f is equals to n plus 1. E is equals to 2n, V is equals to n plus 1. So f minus E plus V is equals to 2n plus 1 minus 2n plus n plus 1. This n plus 1, this n and n will be 2n. This 1 and 1 will be 2. This minus 2n will be as it is. Now we can see this plus 2n and minus 12 got cancelled or got subtracted, and we will get 0 and we will left with only 2. So that means when you have a pyramid with having n sides, then also you can prove the Euler's theorem. And this is the last part of this chapter.